adding or subtracting rational expressions with like denominators. So our question is, what are the steps for adding and subtracting fractions with like denominators? And we have to remember that fractions are rational expressions. When we first take a look here, again, we have two fractions, 3/10 plus 5/10, same denominators. Our process is that we're going to keep the denominator and we're going to add or subtract the numerators. Here we have 3 plus 5, which would give us 8. We then would have to reduce it by dividing the top and bottom by 2. And what that would give us is 4/5. So basically, we kept the same denominator, add or subtract the numerator, and simplify. So if we kind of recorded our steps thusly, we would find out that when the denominators are the same, add or subtract the numerators, and we're going to rewrite the fraction in lowest terms. And again, to remind ourselves that that means that we need to simplify. Okay, so let's kind of take a look at a problem here. Here we have 8x divided by 4 plus 6x divided by 4. If we keep that denominator 4 and add the numerators 8x plus 6x, we will get 14x divided by 4. We recognize that 14 and 4, that 2 can go into both of those numbers, and therefore simplifying it just a little bit more, and that would give us 7x divided by 2. Here's a little bit more involved with binomials. We have x squared divided by x squared plus 2x minus 8 plus negative 3x plus 10 divided by negative x squared minus 2x plus 8. We notice the denominators are not exactly the same, but they're exactly opposite. Here we have a positive x squared, here a negative x squared. Here a positive 2x, on the other side a negative 2x, negative 8, positive 8. Because of that, we can take a look at this one and factor out a negative 1. If we factor out a negative 1, it will change everything inside here, and it would look like this. Now you'll notice that I also factored out a negative 1 in the numerator. The reason I did that is so that those negative 1s could cancel, and then all of a sudden now I have like denominators. I'd have to get rid of it in order to have like denominators. So now my numerator, when I add everything together, will be x squared plus 3x minus 10, all divided by x squared plus 2x minus 8. We're going to factor both those trinomials into two binomials, the numerator x plus 5 times x minus 2, and the numerator x plus 4 times x minus 2. Those x minus 2's will cancel and go away, leaving us with just x plus 5 divided by x plus 4. Now let's take a look at some problems and see if we can apply the knowledge we've just seen. Here we have 3a divided by 5 plus 2a divided by 5. We're going to keep our denominator of 5 and add our numerators, 3a plus 2a, which is 5a. We're going to proceed to simplify because this is 5 times a. Any number over itself is equal to 1. So basically we end up with 1 times a, so our answer is just the letter A. This time we'll do it again in a subtraction problem. Keep the denominator of 10 and subtract the numerator. 7s minus 2s is 5s. Again, we can simplify the numerator and denominator by dividing the top and bottom by 5. That'll give us just a plain old s divided by 2. Let's look at one more simple one. 6b squared divided by c plus 7b squared divided by c. We're going to keep the denominator of c. Our numerator 6b squared plus 7b squared gives us 13b squared. And everything here is prime. Nothing is common. We have nothing left to cancel. Let's take it a little bit more difficult. Let's do some binomials. Here we have 4x plus 3 divided by x plus 2 plus 3x plus 4 divided by x plus 2. So we're going to keep that denominator of x plus 2, and in the numerator we're just going to write down everything we see. So 4x plus 3, because of the plus sign I can just keep writing all the way across. Then what we're going to do is we're going to collect like terms. So we're going to look for things that are alike. Here we have a 4x and a 3x that are going to go together, and the 3 and the 4 are going to go together. So we're going to combine those like terms. 4x plus 3x is 7x, and 3 plus 4 is 7. And we're going to divide that by x plus 2. Now the denominator x plus 2 is fully factored, but the numerator is not. The numerator has 7 as its greatest common factor, so we'll pull that 7 out and have x plus 1 as the remaining factor. Now we can see that the denominator and the numerator, there's nothing that's common. The binomials are different, so there's nothing we can cancel. But you don't know what there is to cancel until you fully factor. So always kind of take a note to yourself to fully factor all binomials, trinomials, because that way you can really see what's happening. Let's take a look here at another problem, this time a subtraction problem. A minus 6 divided by a plus 1. And we're going to subtract 3a minus 4 divided by a plus 1. So let me here kind of play a little devil's advocate here and get rid of something. And let's try and remember and remind ourselves about subtracting things. You don't want to just say this is a minus 6 minus 3a minus 4. We're not just subtracting a 3a, we're subtracting this entire binomial. By doing so means that we have to extend that negative not only to the 3a but also to the negative 4. So we want to make sure that when we do rewrite this in our numerator, it'll be minus 3a plus 4. So let's kind of take a look at that and do our rewriting. So our numerator, a minus 6 minus 3a plus 4, and our denominator of a plus 1. We're going to put things together that are alike. Again, our minus 3a and our a are going to go together, and our negative 6 and positive 4 are going to go together. So a minus 3a is negative 2a, negative 6 plus 4 is negative 2, and we're going to divide that by a plus 1. Now we're going to do some factoring. In that numerator, we can take out a negative 2, leaving behind a plus 1. And in the denominator, we have an a plus 1 as well. We know that these a plus 1s will cancel because they are like in the denominator and the numerator are like binomials. And that means that our final answer to this problem is just negative 2. We'll look at a couple of more, a little bit more involved with some binomials leading to trinomials. Here we have a subtraction problem, y squared plus 5 divided by y plus 2, and we're going to subtract from it 4y plus 17 divided by y plus 2. So once again, we're going to keep that denominator of y plus 2. Our numerator, y squared plus 5 minus 4y minus 17. And again, we're going to take our common ideas, and here we just have a 5 and a negative 17 as our common terms, and we're going to rewrite this, and when we rewrite it we'll get y squared minus 4y minus 12, and we are going to divide that by y plus 2. Now we have to remember a couple of things about our factoring. When we want to factor a trinomial, we can use the diamond to help us get there. A times c, the coefficients of a times c on top, and the coefficient of b is going to go here on the bottom. And we're going to think of two numbers that multiply to give us negative 12 and add together to give us negative 4. That would be negative 6 and positive 2. And we're going to use these numbers to rewrite that trinomial to be a polynomial, y squared minus 6y plus 2y minus 12. That way we can use grouping, pull out the y, leaving behind y minus 6, common binomial on the other side. We're going to add 2 to get us back one step, pull out that common binomial of y minus 6, and so we'll get y minus 6 times y plus 2 as the factorization of our numerator. And we have a denominator of y plus 2. We're going to cancel alike binomials. So then our final answer to this, or simplification of this, is just y minus 6. We're going to do it one more time. 1 minus x divided by 2x squared minus 7x plus 5. And from that, we're going to subtract 3 minus 3x with the exact same denominator of 2x squared minus 7x plus 5. So we'll have 1 minus x. Since it's a subtraction problem, we'll change both signs. Negative 3 plus 3x. We'll put together things that are alike. The x's will go together, and the constants will go together. And what that'll give us is 2x minus 2 all divided by 2x squared minus 7x plus 5. When we take a look at our numerator, we can factor out our greatest common factor of 2, leaving behind x minus 1. And we're going to use the diamond method to help us figure out our trinomial on the bottom. And so what we need is to have a positive 10 because it's a times c, so 2 times 5 on top, negative 7 on the bottom. We're going to use both of these are going to be negative 5 and negative 2, and rewrite this middle term. So we get 2x squared minus 5x minus 2x plus 5. Cut it in half and find the greatest common factor, which is x. Multiply it times 2x minus 5. We notice that it's opposite of each other, which means that this factor would be negative 1. Pull out the common binomial of 2x minus 5, leaving behind x minus 1. So here's our two binomials that we can factor that trinomial with. So 2x minus 5 and x minus 1. We're going to cancel the alike binomials, x minus 1, and then our final answer then will become 2 divided by 2x minus 5. We have to remember we cannot cancel these 2's because this 2x minus 5 is a binomial that represents a particular number. It is not a 2 standing by itself, so we cannot cancel those 2's, and that's our final answer or final simplification of this problem. Hopefully that helps you to understand adding and subtracting rational expressions with like denominators.